Hi everyone. So this is our free preparation series of Capgemini, and in this video I will be solving some pseudocodes because as we all know there will be total 25 questions from pseudocode. That's why it is a very important topic. And if you don't know the level of the Capgemini, you will be familiar with the level in this video as we will be solving the exact question asked in Capgemini this year. I already have the screenshot of the questions as well. You can see here, but the main thing is I cannot show you the screenshot in this video, but we will be solving the exact questions of Capgemini. Also, if you want the full paper of Capgemini, okay, that we already updated in our course, so let me show you. Okay, so the link of the Arjun series you will be getting in the description. So basically, it's a mock test series for all the companies, and if you want to prepare for any company, you will be getting a lot of things here to prepare. Okay, for Capgemini also we updated the two question paper, the exact full set of Capgemini, which you will be getting here if you will go in company wise material. You can see here Capgemini full paper we have already updated. Okay, so you will be getting the questions of Capgemini here. And for practice, we have provided a lot of practice sets. Like if you want to practice pseudocodes, there are a lot of mock tests available. We will be adding some more mock tests here for pseudocodes. For CS fundamentals, also Capgemini asked the questions, so that we also added. Gamified they asked, so gamified also we have added. So a lot of things you will be getting, not only for Capgemini, for any company you can use this series for your preparation. All the mock tests are with timer with solution. Okay, so let's start this video with the pseudo codes, with the exact pseudo codes which Capgemini asked. Also, believe me, when you will be giving the exam, you will remember my videos because I am teaching you the exact thing which will come in exam. Okay, I'm not teaching you anything from internet. I am teaching you the exact Capgemini thing. Okay, I am not teaching you any generic thing, and believe me, it will help you a lot. We will be understanding three to four type of questions which Capgemini ask every time. These are the most repeated questions from Capgemini. That's why we will solve them in this video. And make sure to like this video. Also, the free series playlist you will be getting in the description, like in the pin comment. We have a lot of videos in the free series, so you can also follow our free series. Okay, so let's start. And I hope you already liked. So this is the first type of question where they will give you one graph, and based on the graph, they will ask you some questions. So this is our first type of question. This is the graph based. Okay, basically they will ask you majorly the questions from either BFS or DFS. Very popular question. They will give you a graph. They will ask you the traversal of the graph. Okay, either BFS traversal or DFS traversal. Very common question in Capgemini. You can get like 1 to 2 questions from this topic in your pseudocode. So let's solve this. So this question they asked this year, so let's solve this one. So this is the question. Like a microservice dependency graph is represented using an adjacency matrix. The graph is undirected and contains 6 services labeled S1 to S6. Okay. So see, how many services are there? Total 6 services. S1 to S6. Okay, this is clear. The graph is undirected. This is very important. Okay, undirected graph means, see, if suppose we are going from 1 to 2, so we can also come from 2 to 1. Okay, so any vertex between them, like 1 to 2, okay, we can travel from 1 to 2 and we can travel from 2 to 1. So this is the property for undirected graph. This is very important. Okay, so okay, so this is the representation which they have given. S1 0, S2 1, S3 2, S4 3, S5 4, yeah, S5 6. The ages in the graphs are S1 to S2, S1 to S3, S2 to S4, S3 to S5, S4 to S6, and S5 to X. Okay, which corresponds to the age list like this one, like 01, 02, 13, 24, 35, and 45. To better understand this, let's create a graph. So from 0, it is 0 to 1 and 0 to 2. Okay, 0 to 1 and 0 to 2. Then 1 to 3, 1 to 3, and 2 to 4, 2 to 4. Okay, 3 to 5, okay, 3 to 5, and 4 to 5, so 4 to 5. So this kind of graph you can see here. So this kind of graph they told us. Okay, the adjacency matrix is built using that the matrix of u and v equals to 1, and matrix of v and u equals to 1 for each age u and v. Okay, this is the basic property of undirected graph. A DFS is performed starting from the vertex 0. So they are saying from vertex 0, we are doing an DFS. Okay. Assume the DFS visits adjacent vertex in ascending order of vertex index. Which of the following is the correct DFS traversal? Okay. So they are saying like when we are starting our DFS traversal, it is going adjacent ascending order. Okay. So what will be the traversal of DFS? Okay, so I hope you guys already know the basic property of DFS. Then I will tell you how to solve these kind of question in 1 minute. Okay, because basically in exam you will be getting a 1 minute timer. Okay, so I will tell you how to solve it in 1 minute. Okay, so to explain it better, see, listen carefully. They are saying we need to go to ascending order. Like from 0 we have two options, either we can go 1, either we can go 2, but the point is very important because sometimes maybe it can be random. From 0 we can go to 2, but no, they're saying we are going in ascending order. That means from 0 we will go to 1. Then what will be the traversal of DFS? Okay, now DFS is basically depth first search. Okay, that means we will be going to the depth of the edges or vertex. Okay, so how we do the DFS is basically you will start with the point and you will go to the depth of it. Okay, so if you are starting with a 0, you will not see the neighbors, you will just go in one direction. So from 0 we will go to 1. Okay, from 1, now we will not go again from 0 to 2, then it will become BFS. Okay, so we traveled from 0 to 1. Now from 1 we will travel 1 to 3, then from 3 we will be traveling 3 to 5, then 5 we will be traveling 5 to 4, and from 4 we will be traveling to 2. This will be our DFS traversal. Okay, if it would be BFS, then we will be covering the neighbors, but it is DFS, that's why we will be going in only one direction. So our traversal will be 0 to 1, 1 to 3, 3 to 5, 5 to 4, and 4 to 2. This will be our traversal. Okay, so let's take our correct option. Why I am telling you in detail, because it is one question which they asked, but there is a possibility maybe they will be asking some more complex question there. So that's why 0 to 1, 1 to 3, 5, 4, and 2. This will be our answer, which is answer number B. Okay, so this will be our DFS traversal. So DFS and BFS traversal, they are asking a lot. Okay, now let's talk about how to solve it in 1 minute. Okay, in 1 minute, if you want to solve it, see, first of all, just see some basic details that the graph is undirected, 6 services. See this one. This is very important. See this. Okay, it is the corresponding aging list already given, and perform the DFS is starting from vertex 0. Okay, these are the basic details and from ascending order. Now, how you need to solve it in 1 minute only? Start from this one. So first 0, we will travel to 1. Okay, this one. Now we already reached out to 1, so we will look here where is the 1. So 1 is here. Okay, 1 is here. So from 1 we will travel to 3. Now look here, where is 3? 3 is here. So from 3 we will be traveling to 5. Okay, now look for 5. Where is the 5? Here is 5. So from 5 we will be traveling to 4, and from 4 we will be traveling to 2. So this is our answer: 0 to 1, 1 to 3, 3 to 5, 5 to 4, and from 4 to 2. Final answer. In 1 minute you can solve like this. Okay, but suppose if the graph is little bit complex, okay, if the graph is little bit complex, you need to use a little bit more mind. Okay, that's why I would suggest you to actually understand DFS and BFS in very detail from Google and or from any video, so that you can solve the question from it, because they are asking a lot of question from this. Okay, second question, same question. Okay, same question, second question. Okay, the question is same, just the difference is they are asking for BFS travel. Okay, again the graph is same from 0 to 1, 1 0 to 2, from 1 to 3, from 2 to 4, from 3 to 5, and from 4 to 5. Now they are asking about the BFS travel, how we will perform the BFS travel in here. Okay, so See, BFS travel is a neighbor travel. Okay, you can say it's a neighbor travel. Okay, so we will be covering the neighbor, and based on the neighbors, we will be traveling. So see, first of all, we will print 0. Okay, because we are starting with 0. Now see the neighbor. The first neighbor is 1 and second neighbor is 2. Okay. So write 1 here. Okay. Write 1 here. Okay. Don't write here 2. Okay. First of all, write 1 here. After writing 1, then write 2. Okay. Now this is from 0 we started. This is the first neighbor. This is the second neighbor. Okay. Now have we explored the first neighbor? No. Zeroth, all neighbor we have already discovered. So 0 is gone now. We need to discover the neighbors of 1 now. So what is the neighbor of 1? 3. So we will add here 3. Okay. Is there any or more neighbor of 1? No. Now 1 is also discovered fully. So 1 is also done. Now we will again move forward. 2. What is the neighbor of 2? 4. Is there any other neighbor of 2? No. So 2 is also explored. So 2 is done. Now we have 3. What is the neighbor of 3? It's 5. Any other neighbor? No. So 3 is also discovered. We will go to 4. Fourth neighbor is 5. So 5 is already there. Okay, so all the neighbors is discovered. So fourth is gone. Fifth neighbor is for 5, the neighbor is 3 and 4. Both are already discovered. So fifth is done. So our final answer will be 0, 1, 2, 3, 4, 5. This will be our BFS travel. So it will be 0, 1, 2, 3, 4, 5. Answer number 1. Okay. Next question. Again, a very important question. So they ask case-based questions, case-based question on trees. Okay. Some students actually get scared after seeing this question, but these questions are not tough. You can easily do in 1 minute. Okay. Let's see here how we solve this. A company models two different coaching strategies for its cloud data center. Another thing which I want to tell you, if you want to practice and if you want the exact question full list, the solution I am talking about, all the screenshot of the questions are also available because these are the exact Capgemini paper, and we have already updated the paper here in our Arjun series mock test. So you can get the paper here in the company specific section. And to practice the mock test, we have already added the mock test here, which you can see here. A lot of mock tests are available, like 17 hours of mock test available in CS fundamentals, 6 to 7 hours mock tests are available in pseudocodes. We will be updating it more. Okay, so let's discuss about this now. A company models two different caching strategies for its cloud data center. Each caching strategy is represented as a binary tree. Cache design T1, balanced hierarchy. Okay, so they are saying they designed total two caching strategies. The first one is balanced hierarchy. The root is A has children B and C, B has children D and E, C has children F and G, and D has children H and I. So this is the tree representation. Okay, see here. This is the root, then it has B and C, then B has D and E, F and G, and D have H and I. Cache design T2. Okay, skewed hierarchy. Root is R has children S and T, S has child U, and T has child V. So this kind of representation is there in skewed hierarchy. Okay. Now, matrix definition. The performance matrix of T1 is the height of cache tree plus number of leaf caches, and the compliance matrix of T2, okay, is height of cache tree plus number of internal caches. Okay, don't be scared, I will be explaining you what they are saying. What is the difference between the performance matrix of T1 and the compliance matrix of T2? Okay, let's understand the question. They have given us the tree till now. Okay, just understand the question. Two trees they have given. The first one is there. Okay, the second one is here. Okay, till now the question till now only represents two trees. Okay, now they given two formulas, one for performance matrix and second one is compliance matrix. Okay, now they are saying what is the difference between the performance matrix of T1 and compliance matrix of T2. That means in the final we need to do T1 minus T2. Okay, so first we need to compute T1. What is T1? T1 is height of cache tree. Okay, height of cache tree plus number of leaf caches. So what is the height of this tree? See here, the longest till longest node we will be seeing the height. So from A to B, B to D, and D to H, the height is 4. The height is 4, right? So the height of the tree is 4. Okay, plus The number of leaf, how many leaves you can see here? 1, 2, 3, 1, 2, 3, 4, 5. So 5 leaves are there. So it's 4 plus 5, which is 9. Okay. So the value of T1 is 9, right? The value of T1 is 9. Okay. Now we need to compute the value of T2. The height of cache tree plus number of internal caches. What is the height of this one? Which is 3. R to S, S to U. Okay. Height is 3. Okay. Number of internal caches, internal nodes. Okay. How many internal nodes you can see here? 1, 2, 3. 2 are the leaves, right? So it's 3 plus 3, which is 6. Okay. Now we need to find out. So value of the T2 is 6. Value of T1 is 9. Now we need to find the difference between T1 and T2, which is 9 minus 6. The answer will be 3. Simple. Okay. So answer is 3. Okay. Let's talk about another question. Now, this is the question which is very important, and please practice this question, which is convergence. Prefix, infix, postfix. Okay. These kind of evaluation 1 to 2 questions you can get in your Capgemini exam. Very, very important. The questions are easy. You can easily do in 1 minute. Okay. But a practice is needed. Like, see, I am teaching you the questions. Okay. I read data structures and algorithms in the year of 2020. It's 5 to 6 years. Okay. And I am teaching you this now because my concepts are still clear. Okay. I have a lot of practice. I solved a lot of questions. So the practice and the concepts will be in your mind if you understand that things carefully. Okay. And I am sure that I can teach the data structures and algorithms also this year. I did not revise it from last 3 years or 4 years. Why? Because at that time each and every concept was very clear in my mind. I practiced a lot. Okay, so practice makes you perfect. That is very, very important. And see, these questions like infix to postfix, postfix infix, these kind of conversion you should know. So convert the above prefix expression into infix notation. Okay, so this is the question which they are asking. This is the expression. Then evaluate the infix expression using the following variables: a equals to 5, b equals to 3, c equals to 10, and d equals to 2. Okay, so this is the prefix expression, and we need to convert in infix. So when we want to convert in infix, we always start with the right. Okay, so this is the simple formula to convert it into infix, which is if there is any variable, put it in a stack. If there is any operator, perform the operation, and then after performing the operation, again push it in stack. Okay. Suppose we will start from here. So there is D. This is our stack. So we will push D here. Then there is C. So we will push C here. Then there is a divide. So if it is an operator, we will pop out the variables, two variables. So we will pop out D and C, and we will perform the operation. So it will be C divided by D. Okay. Now this is our operation. So we will pop out this, pop out this. Okay. Now our stack will be empty, and we will push it again. So now our stack will be C divided by D. Now we have B. B is a variable, so we will push B here. Then we have A here, so we will push A here. Now we have again our operator plus. So we will pop out two variables, which is A and B. We will perform the operation and we will push it again in the stack. So A and B will be popping out, plus is there, so A plus B will be there. Okay. And we will push the A plus B in a stack. So it will look like this. Okay. So it will be A plus B. Okay. Now our stack is looking like this. It has divided by D and A plus B. Now it has multiplication. So the final answer will be A plus B multiplied by C divided by D. Okay. Now we need to compute it using the variables. Okay. The variables already they have given the value A equals to 5, B equals to 3. It is 8 multiplied by C divided by D. C divided by D, which is 5. Final answer will be 40. Simple. This will be our final answer. Okay, so this is our part one video. I already taught you a lot of patterns in this video, which will be a lot helpful in your Capgemini exam. Thank you so much for watching. The mock test link you will be getting in the description. Thank you so much for watching this video.